Team Animus Ferus is a high school team from Flint Hill School with multiple previous top 5 placements.
Team Animus Ferus UAV Spirit 12 is a custom fabricated quadcopter engineered to lighten the total weight of the craft while maintaining the same capabilities as its predecessors. The quadcopter's pinwheel design allows for an open cavity for the team to harbor electronics. Team Animus Ferus uses a combination of 4 KDE motors and 4 KDE ESCs. Our 4 KDE propellers help to create 30 pounds of thrust per propeller. The craft is powered by two 25,000 mAh 6S LiPo batteries. The area below the craft houses our camera and gimbal as well as our UGV drop system. Though the team planned on autonomous image identification, while testing, it repeatedly identified non-existing targets leading to point penalties. Unable to finish the new software in time, the team substituted the autonomous identification system with a reliable manual image classification system, originally developed by Team Animus Ferus in 2018. Team Animus Ferus will be attempting autonomous flight with an average waypoint accuracy of 93%. The team's confidence in autonomous flight is high. Obstacle avoidance will be attempted by the team with an average stationary obstacle avoidance of 75%. The team's confidence in obstacle avoidance is high. The team will attempt object detection, classification, and localization. The team will be submitting classification and localization data. However, this data is not autonomous and will not be actionable. The team's confidence is high in classification but low in localization. The team will not be attempting mapping. The team will be attempting airdrop with a 100% accuracy in testing. The team's confidence in airdrop is high.
In developmental testing, Team Animus Ferus conducted various simulation, unit, and integration tests in order to assess the reliability and capabilities of Spirit 12. The team conducted simulated tests, which were the basis of the UAV design, and also provided initial testing to Spirit 12's code for waypoint capture performance and obstacle avoidance. Unit testing was used to confirm results from simulation testing while also testing each individual subsystem for expected performance. In integration testing, the team added subsystems to the UAV one at a time to ensure compatibility with the UAS. In full mission testing, the team tested the UAS with all integrated components. Team Animus Ferus conducted 24 autonomous flights on Spirit 12. In early development, the average time spent in manual mode per flight was 90%. The team manually tuned Spirit 12 because the automatic tuning process yielded PID values that made the craft operate in an unstable fashion. After several unsuccessful auto-tune attempts, the team decided to load PID values from our previous UAV, Spirit 11. The team was able to do this because Spirit 11 and Spirit 12 share the same dimensions, motors, ESCs, and propellers. The PID values were then changed based on safety pilot feedback and the oscillation of the craft during autonomous flight as shown in the flight logs. After the UAV was tuned manually, the average time spent in manual mode dropped to 10%. The team began by testing an Arducopter simulation to fly the default mission provided by the Interop GitHub repository. By scoring 5 of these simulated missions, the team was able to individually test waypoint capture performance before flying the drone. The team's average waypoint accuracy in these simulations was 95%. This simulated test acted as proof of concept for the code that loads waypoints from Interop into Mission Planner. In previous years, Team Animus Ferus has stopped the UAV directly above every waypoint. This year, with the change in the grading system, the team will fly through waypoints because there's less emphasis on accuracy. While pausing at each waypoint ensures an accuracy of no less than 97%, the team decided that the reduced waypoint accuracy was not worth the reduced battery drain. To date, Team Animus Ferus has conducted 24 autonomous flights and attempted to capture 153 waypoints. Spirit 12's waypoint capture rate is 100% with the average waypoint miss error of 7%. The team performed simulation testing on obstacle avoidance using Arducopter's software-in-the-loop functionality. The team tested Arducopter's built-in obstacle avoidance process using Dijkstra's algorithm. However, this autonomous obstacle avoidance caused the UAV to stop at every waypoint to calculate its trajectory, leading to a significant loss in mission time and flight range. As a result, the team chose to abandon autonomous obstacle avoidance. Instead, the team will use Mission Planner to autonomously plot points to avoid obstacles in the flight path. The team's competition viewer software also allows the team to see the position of other UAVs in the air. The team performed simulation testing on the new obstacle avoidance algorithm, successfully avoiding 4 obstacles in 2 different missions. The team performed unit testing on the imaging system to ensure that ODCL targets can be identified. The team began by taking images of targets with the camera from the ground. This allowed the team to find the right shutter and focus settings to find targets depending on lighting conditions. Then the team attached the imaging system to the UAV and began taking images of targets. With the camera now moving, the team found that a fast shutter speed was essential to getting recognizable images. The team settled on a 1/8000 shutter speed, which produces visible images in most lighting while getting minimal blur when flying at high speeds. The team's testing verified initial calculations, placing the camera's images at 5 pixels per square inch. The team built software to create a large number of simulated images of ODCL targets for unit testing. By loading those images into the manual target submission system, the team was able to test the imaging system early in the development process. Team Animus Ferus flew the UAV at 100 feet above ground level to capture images of our own targets that the team designed. Upon landing, the team loaded the images into the team's manual target submission system. The GCS operator manually identified these images. 0 incorrect targets were submitted during testing. However, approximately 10% of targets were unidentifiable from the images due to exposure issues with the imaging system. The team performed initial localization tests by using simulated telemetry and images. In these tests, the localization program received, on average, approximately 90% of localization points. However, moving the system into integration testing caused a significant amount of additional error. On real images, the localization algorithm averages approximately 50% of localization points. The program can reliably place targets within the required 150 feet, but error from the imaging system causes a sharp reduction in location accuracy. Currently, the team is in the developmental testing phase of a mapping solution. Upon landing, the team will remove the pictures from the UAV and upload them into a software package used to create a map. If the team is unable to create a map that meets the competition requirements, the team will not submit a map at competition, but rather use the information learned this year to advance mapping performance for the future. The team performed developmental airdrop testing in a 20-foot stairwell with a simulated payload, ensuring that the drop speed would be slow enough for the UTV to survive intact. The team used video analysis to measure the speed at 1.5 feet per second. The team's airdrop is a 2-speed system, so the team had to perform developmental tests to figure out when to begin slowing down the UTV. During this process, the team dropped a simulated UGV and slowed it down too late. The UGV would not have survived this drop. However, once the team began using the current system with the 1.4-second delay between drop and slowdown, the UGV has survived all drops. Animus Ferus conducted a total of 10 airdrops with a success rate of 100%, as all drops placed the UGV within 5 feet. The team has also individually tested the drive-to-location functionality, and after correctly calibrating the drive system, the UGV has stopped within 10 feet of the target every time. As the making of this FRR, Team Animus Ferus has completed 1 full mission test, which included autonomous flight, waypoint capture, stationary obstacle avoidance, ODCL, and airdrop. During this test, the team captured 6 of 6 waypoints with an average accuracy of 93%. During the flight, the UAV successfully avoided the 4 stationary obstacles multiple times. The team scheduled an RTL event at the end of this full mission test to evaluate the UAS ability to avoid obstacles in this mode. The UAV did not avoid the stationary obstacle in its path, resulting in a 75% obstacle avoidance. For future missions, if the team is able to do so, the UAV will be moved to a position where an obstacle is not between the UAV and its landing location. The team's ODCL system was not able to be evaluated from this test as the camera was not turned on prior to the flight. As a result, powering on the camera was added to the pre-flight checklist. The airdrop system was 100% successful. The UGV lowered to the ground from 100 feet, landing within 5 feet of the drop location. The UGV successfully drove to the drive to location and stopped within 10 feet. During waypoint capture, the second full mission test, the team incurred a things falling off aircraft penalty and terminated the test. During the flight, the screws attaching the UGV tether mount to the descent motor vibrated loose, resulting in the UGV plummeting 350 feet to the ground. The UGV is currently being rebuilt and Loctite is being added to the attachment screws. As a result of these tests, the team has high confidence in its ability to perform autonomous flight and waypoint capture, stationary obstacle avoidance, and airdrop. The team plans to conduct 8 additional full mission tests prior to the competition in order to test the airdrop system in ODCL. The team scored 53.6% on its only mission test. The team does not feel this single test is an accurate representation of our score at competition. At competition, the team expects a score of at least 53.6%. As of the filming of this FRR, the team is working on repairing the airdrop system and plans to conduct 8 full mission tests prior to the mission demonstration. Thank you for watching, and the team looks forward to a successful mission demonstration.